Hey, it's your old pal Lucid Stew again with another episode of From Project Spark to C++. This episode we're going to cover operators. An operator is a symbol that causes an action on one or more values. Operators generally fall into one of four categories: arithmetic, assignment, relational, and logical. There are others, but we'll talk more about them as they become more appropriate to the topic. The main thing to understand right now is the concept. Arithmetic operators deliver the sum, difference, product, quotient, or remainder of two values. These will be familiar from math. The result will be a value. Which type of value depends on the circumstance, and I'll cover that in another video. Assignment operators take a value from their right side and assign it to the variable on their left side. The main assignment operator conceptually is the equal sign. The other assignment operators combine the equal sign with arithmetic operators. It's important to note that the equal sign in programming is not the same as the equal sign in math. I'll show you that in a bit. Relational operators compare two values and deliver the validity of their relationship to each other. The result will be in Boolean form or true-false. Logical operators are like the relational operators in that they compare the validity of the relationship of values, but this time as a whole. Their result will also be in Boolean form. Luckily, these basic operators carry over exactly in Project Spark, so we can give good examples that will look similarly in C++. Let's take a look in Project Spark first. Here are some arithmetic operators acting on values. The result is then assigned to a variable using the equal sign, which is the assignment operator. If you're not familiar with modulo, it divides the first value by the second, and the result is the remainder. 2 goes into 2 one time evenly, so the remainder is 0. In C++, the increment and decrement operators increase or decrease a value by 1 respectively. Project Spark doesn't have an exact analog, but using the increment by and decrement by tiles with an amount of 1 is functionally the same. Project Spark only uses the equal sign assignment operator. The functionality of the others can be mimicked in the way shown here. As we'll see shortly, some operations can be done in various ways, and some of the C++ operators are basically shortcuts rather than unique ideas. You'll notice these relational operators are on the when side of these lines as opposed to the do side like the others have been. This is because relational operators evaluate the relationship between values. Here, the do side will only function if the evaluation is true. Otherwise, nothing will happen. The code on the do side is identical in these lines to emphasize that the important aspect of the relational operators is in the evaluation and not what happens because of it. Same thing with the logical operators. The difference is that we're not evaluating how the values relate to each other, but rather the conditions as a whole. Line 1 will only fire if the Boolean variable is false. Line 2 will only fire if the number variable is equal to 2 and the Boolean is true. Both conditions must be true. Line 3 will run if either condition is true, but at least one must be true. Again, the code on the do side is identical in these lines to emphasize that the important aspect of the relational operators is in the evaluation and not what happens because of it. And now the same setup in C++. Notice the similarity to the code in Project Spark. On line 3, I'm declaring and initializing this integer variable so that we can use it in subsequent lines. We'll talk more about data types, declaration, and initialization in the next couple of videos. Jump back to about 1:45 real quick and check out how similar these statements are to the same ones in Project Spark. Again on line 3, declaring and initializing an integer variable. The initial value of number is 2. See if you can work out why the values change the way they do in lines 4 through 8. We can look at our relational operators from a Project Spark perspective by seeing one part of each, like the when side of a Project Spark line, and the other part like the do side. Each line uses the if keyword to set up a conditional evaluation, which causes a statement to result if the condition is met. Dipping our toes into punctuation for a minute, you'll see we're using parentheses to surround our conditions, curly braces to surround our statements, and semicolons to signify that our statement is finished. This works a bit like a period in a written language. It probably looks familiar at this point since I've used it many times in examples already. Applying what we just learned about punctuation, hop back to about 3 minutes 15 seconds and look at how similar these C++ logical operations look compared to the same ideas in Project Spark. As I said previously, some operators act sort of like shortcuts. Lines 5 through 7 are an example of some redundancy across operators. All three of these lines are doing essentially the same thing. Line 7 is a good example of how the equals sign assignment operator is definitely not the same as equals in math. If we were to balance that equation, we would end up with 0 equals 1, which is obviously incorrect. It's important to remember that the equals sign in programming means that the left-hand side is being given the value of the right-hand side. Equality doesn't have anything to do with it. Kind of the same idea here, where we're replacing the greater than equals and less than equals relational operators with two relational conditions in the logical operator OR. The code is functionally the same, but obviously the greater than equals and less than equals operators are quicker to code. Well, that's all for this episode. In the next video, we'll cover data types and then on to declaration and initialization. See you next time.